Hello everyone. Today we will see a derivation for force exerted by a flowing fluid on a pipe bend. Now it is based on the concept of momentum equation, that is impulse momentum equation. To derive this expression, let us consider fluid is flowing through a pipe which is bent as shown in figure. Consider two sections, section 1 and section 2. Now, let V1 is the velocity of fluid flowing at section 1, P1 is the pressure of fluid flowing at section 1, and A1 is the area of section 1. Similarly, V2, P2 and A2 is the velocity, pressure and area for our section 2. Now, Fx is the force exerted by flowing fluid on the pipe bend in x direction. Fy is the force exerted by the flowing fluid on the pipe bend in y direction. Now, as we said, Fx and Fy are the components of the forces exerted by flowing fluid on a pipe bend in x and y direction respectively. Therefore, pipe will also exert a force on flowing fluid. So, according to Newton's third law of motion, the force exerted by pipe bend on flowing fluid will be exactly same, but it is in opposite direction. That's why we have considered it as minus Fx for x direction and minus Fy is in y direction respectively. This is the force exerted by the pipe bend on flowing fluid. There will be some other forces also acting on the flowing fluid, like pressure force which is acting at the section 1, which is P1 A1, and second pressure force exerted at section 2, that is P2 A2. Now, with respect to P1 A1, Fx and Fy, this particular pressure force at section 2, it is inclined one, and we need to resolve it along into its two component. That is, we resolve it with respect to angle of inclination theta. So the component of this pressure force along y direction, it is P2A2 sin theta, and along x direction it is P2A2 cos theta. Similarly, for the velocity at section 2, it is V2 cos theta along x direction and V2 sin theta along y direction. Okay, now next. Now, we need to apply the momentum equation in x direction. Momentum equation, it is nothing but the net force acting on a fluid in x direction. It is equals to rate of change of momentum in x direction. Or in another term, we can say that Fx is equals to m into final velocity minus initial velocity. So, the forces along x direction, the first force, that is P1A1, which is positive, it is along the direction of flow. Second pressure force, that is the resolution of our second force, that is P2A2, and which is P2A2 cos theta, it is opposite to the direction of flow, that's why it is minus. And second, it is the force exerted by pipe bend on the fluid flow, and that's why it is minus, it is in opposite direction. Is equals to mass per unit time multiplied by change in velocity. Now, mass per unit time, it is nothing but the product of mass density multiplied by discharge. So, our equation become P1A1 minus P2A2 cos theta minus Fx. Now, we have replaced this mass per unit time with the product of mass density multiplied by discharge. Okay, and change in velocity, but obviously final velocity in x direction minus initial velocity in x direction. Now, we know that the final velocity in x direction, it is v2 cos theta, and the initial velocity in x direction, it is v1. So, our equation will be modified to P1A1 minus P2A2 cos theta minus Fx is equals to rho into q in bracket v2 cos theta minus v1. Okay, now which is equal to, again, if we want the force along x direction, that is fx is equals to rho into q v1 minus v2 cos theta plus p1 a1 minus p2 into a2 cos theta. So now we have seen it for our x direction, that is force along x direction. Now with momentum equation in y direction. Now momentum equation in y direction, it is same, that is net force acting on a fluid in y direction is equals to rate of change of momentum in y direction. Similarly, we need to find out the forces along y direction and change in momentum in y direction. So for our first section, there is no force with respect to y direction, so we cannot put here any force. But for second section, we have resolution of P2A2 along y direction, which is P2A2 sine theta, and it is in opposite direction. So that's why it is minus P2A2 sine theta. Minus Fy. Fy is again the force exerted by a pipe bed on a flowing fluid, which is opposite to the direction of Fy, and that's why it is minus Fy. Is equal to, again same, that is mass per unit time multiplied by change in velocity. Again we know that mass per unit time, it is nothing but the product of mass density multiplied by discharge. So that's why we replace here mass per unit time by product of mass density into discharge, final velocity in y direction minus initial velocity in y direction. So now in this case, we don't have a initial velocity along y direction, we only have the final velocity in y direction. So our equation become minus p2a2 sine theta minus fy is equals to rho into q v2 into sine theta minus 0. If you want the formula in terms of Fy, then Fy is equals to rho into Q minus V2 sin theta minus P2 A2 sin theta. This is the force exerted along y direction. Now, we have find out the force along x and y direction. Now, we want the resultant force. So, the resultant force Fr is equal to square root of Fx square plus Fy square, and the angle made by the resultant force with horizontal direction, it is tan theta is equals to Fy upon F. For more theory and for more numerical, you can refer the textbook of Fluid Mechanics by Dr. R.K. Bansal. Thank you.